I'm Paul Speciale. I'm the Chief Product Officer at Scality. This session today is going to focus on the demands on data storage from new cloud-native workloads that we see emerging across industries of all types. So let's go ahead and get started. For us, really, the starting point is all about the data. And if you had asked people, even 10 or 15 years ago about the data that they were managing in the enterprise, you probably would have gotten a very different answer than what we're hearing today, right? People would have said data is databases. It's things like, records in row and column format. Relational databases were quite common. Other people might have said documents. But I think now in 2021, the data variety, the formats, the capacities are just so much more varied. We see things like AI/ML data, big data for analytics applications, but also data being emanated from lots of machine-generated applications like devices and sensors. But it also includes all the data that we still work up daily, right? Backups are certainly data, log files, archives. There's really no shortage of it. And I think one core observation here is that it's unstructured data that's in the form of all of these different types of files and objects. That's really sort of the dominant source and the amount of data that we need to manage these days. So that's where we're going to focus, is a little bit more on this unstructured data side. If you look at some of the well-known analysts, for example, IDC, they have studied this world quite extensively. Their projection is that something like 80% of the growth of all of the data comes from unstructured data. They've also looked at this emerging world of cloud-native apps. Their estimation is that most, if not all, of the new applications being developed will be cloud-native, so developed and delivered as containers, deployed and orchestrated on Kubernetes, something like 90% of them. Over 90% of these will actually embed artificial intelligence and machine learning. This certainly has a bearing on the amount of data, the type of data that applications will generate and consume. Certainly, it will increase the amount of data that we deal with. IDC also had a study that cloud-native applications will tend to generate 10 times more data than legacy traditional applications. And I do believe it, right? It's something where it's more natural that they deal with more users, more media type of data, and I think that will result in more and more application data being generated. Look at this case study from JPMC, JP Morgan. They're obviously a very large example, but they are refactoring something like 6,000 applications to be cloud native, and they deal with hundreds of petabytes of data as a result. So this is really a huge example, but I think it shows the trend into the mainstream for cloud native. All right, so let's think about a little bit more about what type of workloads will be driving these new data demands. We mentioned artificial intelligence and machine learning. We all hear about it. It's sort of starting to become blurred with big data analytics. I think there will be a component of AI/ML in many of these different domains. We certainly also hear about a new class of edge applications that are emerging. I mentioned machine-generated data, things like cameras on the edge, but also sensors and devices within factories, even vertical industry-specific devices like in medical, healthcare applications. You have, medical image scanners, but there's really no shortage, right? You can think about the edge as representing anything from an automobile to an aircraft to a mobile user device. Certainly the data is being consumed and generated there. Media content, there's no shortage of different types of media delivery formats, whether it's streaming or live TV or cloud DVR. These are obviously very data intensive type applications. Looking at sort of the classical backup and data protection apps, the need to store this type of data for longer term retention, to protect against ransomware threats, that's certainly increasing the amount of data that those kind of applications will deal with. And ultimately, just a whole new set of cloud services, software as a service type deployments. All of this is very data rich and will have a bearing on how much data needs to be stored and managed over the long term. One of the evolutions that we've seen in this time also is this change from applications that more naturally use POSIX file system to those that are embracing object storage. Object storage has been, available in some formats for 15 to 20 years. I think we all understand that object storage has advantages in terms of creating bigger namespaces, more scalability, The minute you need to start thinking about storing and managing millions to billions of objects, object storage starts making more sense versus the traditional file system model. This really means that we need applications to understand this model more naturally, rather than dealing with a hierarchical namespace where you have directories and subdirectories and files within that, and you need to access by path to navigate to the file. Now you have this different model, right? You have an API-based access to object storage. The popular API these days is pretty well established, is the Amazon S3 API. And what you have here is a flat namespace. You just access the objects by ID, and that obviously reduces the overhead on the storage side to be able to track and retrieve this type of data. So we see this happening now. More and more applications across the industry spectrum are embracing object storage for this reason. We also starting to see this happen now in Kubernetes. So obviously now we're going to develop software, deploy them as containers, package them and deploy them as containers on Kubernetes. This type of workload will become more prominent on top of Kubernetes. CSI, the container storage interface, has been available for the last few years for making it easier to provision block and file storage for applications in Kubernetes. It lets them stand up a volume through an API. There is now an analogous standard for object storage provisioning that is emerging for Kubernetes. It's something called COSI, Container Object Storage Interface. That's something that will make it easy for applications running on Kubernetes to provision object storage buckets. And clearly, object storage from the Amazon S3 API perspective is really the de facto standard. It's being embraced both by software developers and as well as object storage and storage vendors themselves. So we think that container-based storage services on Kubernetes will naturally leverage these APIs, both for data access and for provisioning object storage. So this is happening. So one of the other things we want to talk about here is independence of scaling capacity and performance. This has not always been true before. If you looked at things like Hadoop and the Hadoop file system, the way you grew it was to grow both compute and capacity in lockstep. So they were sort of coupled. You added a new server. That server would be added to the HDFS pool, for example. It would thereby add more capacity and more performance together. Sometimes you don't need that, right? Sometimes you only need more capacity or you need more performance for a given workload. So doing this in kind of this locked, coupled model does present a significant waste of resources in some case and unnecessary cost. The new model lets us decouple that. Okay, so you have an application. Let's say it's a new AI ML application. It may be very CPU and memory intensive. In that case, you want to dial up the amount of compute resources, but the amount of storage you have already deployed may be sufficient. Okay. On the other hand, you have some deployments where you need a lot of capacity, relatively lower bandwidth on storage or lower IOPS. You can scale that independently. What's the end result? Much more efficiency, right? Less waste, reduced cost. So we want to get to this model. We do see this happening now in the industry. Applications are embracing object storage. The new models embracing object storage do indeed decouple compute performance from capacity. Okay, so we're going to reap that benefit. There's a few examples that I've provided here. One is Splunk Smart Store. The other is Apache Spark over what's known as S3A, which is a Hadoop compatible protocol. Other vendors, many other vendors are embracing object storage. I have the example here of Vertica, which is another analytics vendor, leading analytics vendor. They have something called Eon Mode, which works with S3 API. And we have lots of emerging APIs on the S3 side to help optimize search. So things like metadata search. S3 Select is another one. Let's look quickly at some of how these popular applications are embracing S3. So Splunk recently, in the last few years, has put out this model called Smart Store. This ends up being their standard model of storage access. It's really a new model of data management that brings it closer to kind of compute on demand. Okay, so it lets them sort of manage data from a hot, warm, and cold perspective. The idea is that the indexing tier can be scaled independently, the Splunk indexing tier, so they can scale out the number of index nodes, the number of caches that manage the hot and warm data. but they really use API-based access through S3 to the object store for storing persistently the large volume of warm and cool data. Okay, the benefit of this is that the indexing tier here in the middle becomes stateless. That's great for scalability. This means that this can be grown according to any needed workload for performance, but it's automatically using the cache manager to intelligently place data from the object store into the cache as is needed. And again, it depends on the S3 API with the cache manager making decisions to access the data based on access patterns or data age or the priority of the data. Okay, a very nice model that makes things kind of decoupled in this capacity and performance sense based on S3. To provide an example of how that's being deployed at scale, here's kind of a case study of a customer in the financial services industry. This is one of the biggest banks in the United States. They had a business challenge, which is to really create a very voluminous data lake and to make it scalable for all of the financial threat data. Okay, so this is based on Splunk. It is a truly huge one. It ingests hundreds of terabytes of new data per day that needs to be consumed by Splunk. Okay, it's 400 terabytes per day of ingest today. The need is to retain that for a year, so a full 365 days. So you can see how that quickly gets to tens of petabytes. The bank wanted to deploy this under an Amazon-like consumption model, but to keep it on-prem. So they selected HPE and the GreenLake as a service delivery model. The underlying object store is the one from Scality, which is my company. It's an 80 petabyte deployment of the Scality ring on over 140 HPE Apollo storage servers. And even more interestingly, this is deployed on 2 sites. So they have a site A, a primary site, and a secondary site for disaster recovery. The storage system performs the replication between the sites. So you can see how intensive this is. 400 new terabytes per day landing on site A. That 400 terabytes gets replicated to site B, and they can scale this all on demand. So if they need additional capacity, we can do that with no downtime. This whole environment is deployed, the Splunk environment is deployed on HPE's container platform, which uses Kubernetes. So it is a fully managed, containerized, orchestrated environment. And as you can see, the performance here is really impressive. This is 30 gigabytes per second of write throughput, while the Splunk indexer nodes are concurrently accessing the data for read. So they really benefit here from this independent scaling of the compute and the storage tiers. A very powerful example. I mentioned at the beginning that Spark, which is part of the kind of classical Hadoop ecosystem, has also entered this era of being able to embrace object storage. There is a way to present the Hadoop file system through an S3 protocol. There's something called the Hadoop S3A connector. This offers very high performance against both cloud object storage, something like Amazon S3 in the cloud, and on-premises object storage over S3. So S3A provides that view to Apache Spark and allows it to access data in its model, but again, using the S3 API. So this is something that could be deployed uniformly in the public cloud or on-prem, and it works just perfectly well and even very high performance. Okay, so that's a way to use object storage with Spark, Apache Spark. The third example, which is quite analogous to what I talked about with Splunk, is for an application called Vertica. This is another advanced analytics platform. They had the same kind of classical model where they had rigid compute, and storage. As you grew the compute, you'd also grow the storage. Rather inefficient, right? To do that in lockstep, as we talked about. Their new storage model is called Eon Mode. It does leverage S3 compatible object storage. So as you can see now, you can sort of scale for peak workload, scale down for low workload, and really keep things very efficient from a resource perspective. Okay, so those are kind of 3 examples of how new applications, new cloud native applications are embracing object storage. So now let's talk a little bit about, sort of the heart of this talk. What is it that's changing in these new applications, these new cloud native applications that are increasing the demands on data storage, right? So specifically, we're starting to see more big data analytics, AI, ML, and new edge applications that are all sort of demanding higher capacity storage, really massive data growth into the petabytes. One interesting thing is that these applications really deal with a mix of both small payloads and very large payloads. It might be, semi-structured data with some text fields, but it also mixes in image data and video data. They also tend to depend more on metadata, which can often be represented as smaller files or smaller objects. They are very I/O intensive, but in sort of two ways. One is that they might depend on very fast random I/O to do a lot of sort of small files, small I/Os to the storage system with very low latency demands. On the other hand, you have a lot of jobs that are CPU and memory intensive that just need huge amounts of throughput, as we talked about with the banking example, where we needed 30 gigabytes per second of throughput. In the end, we have this huge range of edge applications also coming at us. Those often want to start small. They need a capacity point that's in the small tens of terabytes, but the expectation that they'll grow into the hundreds of terabytes and beyond. So you can see here that there's much more demand coming on storage. And what is really needed to address this in the future is a system that can deal with both small capacities and large, so scale out, but also be expecting to deal with small and large payloads, both from a throughput and an I/O IOPS perspective. Okay, that's a very big change from what we saw 5 years ago. So there are starting to be systems that are being designed in the market and offered on the market that address those needs. There is the emergence of sort of this optimized class of data storage solutions that know how to deal with these new cloud workloads. I'll introduce briefly Scality's product, which is Artesca. It is cloud native object storage. So let's give you kind of the few-minute intro to that. This is the type of data storage solution that's really designed for the Kubernetes era. Okay, it's really designed to think about cloud native workloads, the access patterns, and even the deployment models, right? So deployment on top of Kubernetes, API-based access to data over S3, but also the provisioning access over APIs. Data storage solutions like Artesca are also cloud aware. So in addition to being cloud native, they also provide the ability to manage data that lives on-prem and also to manage data that lives in public cloud. So to kind of cross across the hybrid cloud chasm. So they provide the capabilities to view data no matter where it lives, whether it lives on-prem or in the cloud or even on the edge, and to mobilize that data. So perhaps you need to take data that's on-prem and put it in the public cloud, or to take data that's generated on the edge and move it back to a cloud or a core data center. We at Scality announced Artesca in this space in April of 2021, and it is in itself, in fact, a cloud-native design. So top to bottom, all of the data access and multi-cloud services, the storage layer, and the platform services are all developed and delivered as containers, and it all gets deployed and run itself on Kubernetes. So it's really implicitly designed as a cloud-native application itself, but to manage data storage at scale and at high performance. I mentioned the multi-cloud aware namespace. Here's kind of a representation of the UI. As you can see with Artesca, the data can live locally in Artesca. It can live on a remote Artesca instance. So perhaps you have a large one deployed in a core data center, a smaller one, even though it's not small, still 200 terabytes deployed on the edge. There might be many of those, and you can see them all within this global namespace. Here's an object store, which is also perhaps in a remote data center. In this case, it's a Scality ring. But then we can represent and view and manage data that's also in Amazon S3, in the public cloud, in Azure Blob, in Google, in Wasabi Cloud, and even on tape. People are still very interested in having the cold storage advantages of tape. So multi-cloud namespace really means that data can live anywhere, but the namespace represents that and allows you to manage it. Okay, the type of management policies that are provided in Artesca are things like lifecycle management, so data expiration, data transition based on policies. This really means data deletion based on some criteria, or data movement between storage locations. For example, an Artesca deployed on the edge might capture the data, keep it for 3 months, and then replicate it to an object storage system or to the public cloud, or both. Okay. The other model of data management is to provide replication. Replication can work to single or multi-target. So it might be important to keep data both on the edge and to replicate it to 3 public clouds, for example, for different applications to use it. All of this does follow the Amazon S3 API model. There are APIs called Bucket Cross-Region Replication, CRR, and Bucket Lifecycle for mobilizing that data. So Artesca follows those APIs. Okay, so in the end, what we have here is new application workloads. These are really very cloud native based, so they are themselves delivered and deployed as containers on Kubernetes. That means the demands on data storage are really changing from this class of big data analytics, AI, ML, and edge applications. They really want to use API-based access and provisioning to data storage. These systems also need to be hybrid cloud ready, right, to really manage data across on-prem, cloud, and edge. And Artesca is an example of a product that has entered the market to really provide both cloud native and cloud aware storage for this new world of cloud native applications. So let me summarize by saying there's 3 things to remember here. A rapidly changing world of cloud native applications that are very data intensive, especially in artificial intelligence, machine learning, and analytics. They do get deployed on Kubernetes, and we see dramatic benefits from using object storage in this world, especially as they provide real efficiency in compute and data-intensive applications. So with that, I want to thank you. Please enjoy the rest of the Cloud Native Data Management Day presentations. And if there's anything else you would like to find out about Scality, please visit us at www.scality.com. Thank you very much.